The perpendicular bisector of chord AB of a circle PXAQBY intersects the circle at P and Q. Prove that the arc lengths are equal. So we are looking at, first thing is which we can draw is a chord. So let's draw a chord. Then we need to draw a perpendicular bisector for this. So by default, a perpendicular bisector will pass through the center. And so we have this to be 90 degree also. Of course, they've given it. So this is perpendicular and it's bisecting. So we'll call that as O. Then let's read the question again. If the perpendicular bisector of the chord of a circle, this circle, intersects the circle at P and Q. What does it mean? Yes, this line cuts the circle at P and Q. Prove that the arc length PXA. Okay, now we have to read the circle carefully and fill the blank. PXA. So where is P? XA. Okay, so this would be your X. Or let me make this as P and Q. That will be convenient actually. Doesn't matter actually. But anyways. So this would be X PXA. Or is yeah PXA Q P and this is Y. And now the diagram is complete. So they are asking us to prove PXA, this particular length, is equal to PYP, this length. So that would be our question. So now how will we do this? Think about it. So we have been given QP is perpendicular bisector of AB. And if I call this as M, this point as M, this implies what? This implies we have AM is equal to AMB, where M is point of intersection of PQ and AB. Next, why are they equal? Also, reason being this, that a perpendicular line, where is it? Yes, here. A perpendicular drawn from the center of a circle to a chord bisects the chord, right? And, oh yeah, nothing. They are actually given. My bad. This is given. We are writing in given only. Why am I giving the reason? So next thing is we need to conclude one more thing. Since this is a perpendicular bisector, it will pass through the center, the converse. A line drawn through the center of a circle bisects a chord is perpendicular to the chord. And also we have one more conclusion, as PQ is a perpendicular bisector of a chord, it passes through the chord, through the center, sorry. Okay, this is a fact. Right, making use of this, we have to talk about few more things. So I wrote it off now itself. What else can you tell? Okay, we can't tell anything anymore. So now we have to look at what is that we have to prove, and how to prove it is something that we have to think about. What theorem can we use? Yeah, what theorem can we use? It's over here. Congruent arcs of a circle subtends equal angles at the center. Here we have to prove what? Read the theorem again. We have to prove the converse. We have to prove that equal angles at the center subtends. We'll be using that. Sorry, we'll be using that. Equals angles at the center subtends equal arc length. So basically, we have to prove. Think, what is that we have to prove? If I join this, that is your clue. Yes, we have to prove the following. We have to prove that this angle is equal to this angle. Okay, guys. How will we do that? How will we do that? That's your next clue. Yes, we can make use of congruency. Okay. So which two triangles? OAM and OBM. I hope you guys thought that's the point of whole pausing and all of that. Now the proof. So we have joined joining OA comma OB. Now we'll talk about in triangle OAM and triangle OBM. So why are these two triangles congruent now? You guys have to tell. We have to prove these two angles are equal, remember. Yes, first thing is AM is equal to MB. Okay, because it's given. Then we have OM is common. I'm sure you guys will be able to tell that. Yes, and also angle, correct. Which angle? OMA is equal to angle OMP. Is it not? So we have this both to be equal to 90 degree as OM is perpendicular to, or PQ is perpendicular to AB. Okay, guys. So this is all your given and this is common. Everything is written. And so what can we tell? Correct. Therefore, by what is this? I think RHS. No, SAS. SAS congruency. Triangle OAM is congruent to triangle OBM. And therefore, thus, or by CPCT, what do we have? We have angle AOM is equal to MOB. Angle AOM is equal to angle MOB. Right? So with this, what can we conclude? This implies arc length, whatever the given question is, they are equal. Arc length PXA is equal to arc length PYB. Okay, guys. Right, end of it. What else do we need to talk about? The reasoning. Angles, equal angles at the center. Center of a circle. Center of a circle makes, or how do you put it? Subtends, no. Has equal arc length. Has equal arc length. So that would be our answer.